morning, Durvish, and followed by Anuja, Achal, Ishwari, Sheetal, Tejas, Prajwal, Harshada, Atharva, Prachi, Ashutosh, KR. The ones who are already on the line. You have Viraj, Aditya, and Radhika. All of you all a very good morning. Okay, Rasika, Yuga, and Asmita as well. All of you all wishing you a very good morning. Now, Chinmay, good morning. Well, this being possibly the last week before we go for the Diwali vacation in the sense this year it's all so very absurd that it hardly would sound like a vacation as such. It rather is a short break, I would say. And first of all, let me share with you all that today and tomorrow, Ajit and Swarada, good morning. Today and tomorrow, of course, we will be having our lectures. As far as the lecture for the 17th is concerned, let me tell you that I would still be on a vacation for the 17th. So I will be officially applying for a leave from the college. So 17th, 16th, of course, is going to be our break. If you have received the notice on the group, the Diwali break is going to be from short break is going to be from the 12th, I suppose, till the 16th. Supposed to start on the 17th, but I am going to be on leave on the 17th as such. So next week, technically, we are not going to have any lectures. 16th on the occasion of being a holiday, and 17th I would be not available. So 16th and 17th we would not be having our lectures. Probably next week also there could be a rejigging of the timetable. Purnima, good morning. And we would go back to 3 lectures a week instead of having 2 lectures a week. That's, of course, up to be seen. Then I would now like to just discuss a few things before we go on to what we were doing last time. I will try to share it in a different way. Let me see. I don't know whether I'm able to. You are able to see this, but I wanted to show you all the. Oh God, I have not come up with the screen sharing was cancelled. Just a moment. Give me a couple of seconds before I come down to what we are supposed to be doing all the way. And okay, the PPT that I was supposed to keep ready for today is got delayed, and as a consequence, I'm in this fix, but I'll fix it in no time from now. Okay, this, and let me come down to this aspect as such. Okay, now I was supposed to show you and discuss about the syllabus as such. The reason being that we are partially into the first topic. We have done geography and the branches of geography. Of course, we need to go into geomorphology, and I wanted to speak about geomorphology for a moment. But probably we would be doing it towards the latter part of the day, or let us say tomorrow. Secondly, I have posted a few clips yesterday on the group, and these clips being, both of these being, one is of course a musical one, and another is of course an informative one, both of them of equal value. This is supposed to be with regards to the geological time scale, and if we reach the topic of geological time scale today, I would go into further details of that. I would now start sharing, and we'll start with what we had done last time. I hope you are seeing this on your scene. Just let me switch on my connection wherein I would be able to see whether you all are able to see what we are supposed to be seeing. Anyway, bit of hurry this day, but it's advisable that we go into all those details without any delay. Just give me a couple of seconds more. And yes, there we are. Let me check if we are able to see this in front of me. Seconds more. I will just bring down the volume. Yeah. Yes, I believe you are seeing this. And yeah, there was a question regarding the fact that longitudes was written horizontally, right? And or rather longitude, I don't know which exactly that the girl meant, but this latitude word is written horizontally, and she said that this longitude word is written vertically. Now, as far as these aspects are concerned, I want to make a clarification. I did get to the clarification last time, but because I could not reflect it back to y'all on the screen, I just waited for the day to come. Now you'll see that when it is written latitude here horizontally, it means equator, and this red line is the equator. This red line, which on through which my arrow is moving, is the equator. So the artist wants to depict the line equator, and he she calls it as the latitude. Thus it is written horizontally. And similarly, this line of longitude is nothing but the prime meridian, and the artist wants to imbibe the prime meridian on us, and which she means that is the longitude, 0 degrees longitude. I believe that was the say confusion last time. And thus, because you'll see that here they have written longitudes, okay, they are going from here all the way to here, or rather you could say that from 0 degrees to 90 degrees west are these longitudes. So it's written horizontally. This latitude here is depicting only the equator. This word longitude here, 0 degrees longitude, is depicting only the prime meridian. That is what I wanted to clarify. There was a suggestion from an interesting suggestion from a student that these lectures are getting very monotonous. He stopped short of saying that these are boring. He said it's getting monotonous, and he wanted me to just change a few tones. So believe me, I'm not this monotonous when I'm in the class, but online teaching is new to me as well. Of course, I'm making efforts to bring a lot of emotion into my lecture. So I will try to get in physical expressions using my hands and fingers to express a few concepts also. Okay, so if we are through this, now again, we'll have to wait for your chats that whether this actually was the problem or the problem was something else, if those who were attending last time's lecture remember. Yeah, in continuation of the weather and radar map that I had wanted you all to, there's that app that I wanted you all to download. A few things that I wanted to tell you all is a bit down, you have this towards the left side, this side, you have the weather for map in the pictorial format itself. If you see the one earlier, okay, you'll see that you had clouds nearly in many parts of India, but this taken today, you'll see that you are seeing a lot of sunshine, except for a few places in the southern parts of India. And as far as other parts are concerned, you'll see that all other parts are nearly getting their due sunshine. Okay, so that is what you can also see Okay, you'll see that as we move further south, okay, you'll see that it is getting cloudy near the 0 degrees equator, and of course this would in a month's time from now this would further shift down south as well. So that's an interesting thing. Of course, when you switch on to this, you'll have this now button. If you click on this now button here, you'll have the weather map in the literal sense for the day, for tomorrow, for day after. It gives you the pictures for the next 6 days. Not that it is going to stay as it is, because we all know, and we are going to study this, that weather is a very dynamic phenomenon. It keeps on changing. But given the trends of today, what should be the conditions of the weather in a few days to come is what this app tries to reflect on us. Then this is something we discussed last time. A few more things that I wanted to add to this is that, of course, it gives you the forecast for the day. That's morning, afternoon, evening, and night. Okay, you can go into the details here as such. Then these arrows here, okay, each of them show the direction into which the wind is moving. So for today, I would say that the winds are from the east, blowing from the east towards the west. During the morning, the winds are going to be a bit harder. Okay, and you'll see that as far as the other parts times of the day are concerned, they will be a bit smoother. Okay, now how do you differentiate that? You'll see that the morning wind logo, or the picture that they are using, okay, symbol you would say they are using, is shaded a bit. If it is full shaded, then the wind speeds are going to be further intense. Okay, but as of now, you'll see that it's very gentle. Now, when it means gentle, what does it mean? It's going to be, now you'll see that it's going to be light winds from east and at a speed of around 10 kilometers per hour. So it is going to be very gentle as such. So this is another thing that you can note about. Then a few more things that I wanted to tell you all is you can open up this app every day in the morning, and you can shift it in the afternoon also, and check the air pressures. You'll see that towards the colder part of the day, the air pressures are going to be of higher values, and towards the warmer part of the day, the air pressures are going to be lower as such. And if you go into the this settings button, you have an option of giving you of what calls feels like. Now, what does this feels like mean? Okay, you'll see that the actual temperatures are 22, and they say that yes, it feels like 22 itself. But you'll see that when you go to colder parts, and in fact, if we would note this in the months of let us say December and January as such, you'll see that the temperatures would be low, and in fact they would feel like further low. Now, why does this happen? Okay, you'll see that now this is 22 here and it reads 22 here as well. It's because of the fact that say the amount of water vapor in the air is at least 50%. You'll see relative humidity here is 55%. Okay, now if I remove the water vapor is again a heat soaking element of the atmosphere, or the air, I should be saying. And because it retains a bit of heat, okay, you'll see that there is no difference. But you'll see that when air tends to get drier and drier and drier, okay, that means you are soaking out the water vapor from that. The humidity levels will go down and down and down. Say, for example, you are more towards the tundra region, or you could say that you are in the drier parts, say in the Sahara Desert, etc. You'll see that the feels like temperatures would be lower than what actually are recorded as such. Okay, because a thermometer, remember, is a technical instrument. As far as the body is concerned, you'll see that it responds to a lot of things. Okay, and that is what we need to study as a part of physical geography and human geography. So that's where it starts getting interesting, and that's where it starts getting important as well, that I should be knowing the connections. Okay, the thermometer is an instrument, it's a scientific instrument, but and the thermometer will say will read the literal measurement as per its calibration. But as far as the human body is concerned, okay, you'll see that it would depend on done so many things in the sense that people who are living in that particular area would hardly feel anything, but people who would visit that particular area as a tourist would start feeling chilly if they are coming from India. Okay, so for example, if you're going from India to let us say London or let us say Paris, you would feel the chill the moment you land at the airport. But someone from north, in the sense, someone from Denmark would come down to the same airport, say the London Heathrow airport, or let us say Paris airport, as such, they would be feeling warmer. Okay, so this is very relative, and that is what the theory of relativity is all about. And I'm going to come to that in some moments of time. In the sense, now you will see that let us, for example, now let us take these three values. Okay, the afternoon temperatures, the evening temperatures, and the night temperatures. I'll show you what relativity actually means. Okay, now when I close this, okay, when I close this, okay, please don't look into the morning temperatures, afternoon and evening temperatures. Which of them is warmer? 30 degrees is warmer and 19 degrees is chiller. Okay, now if I take it the other way, okay, and I bring in 15 and 19, now 19 becomes warm. Technically, 19 is 19. It has hardly changed. But just like when we said that because of the tilt in the axis of the Earth, okay, neither the Earth moves this way and that way, and neither the sun moves this way and that way. It's only that the relativity which brings in the seasons. Similarly, you'll see that when I speak about 19 degrees and 15 degrees, now 19 becomes warmer as compared to 15 degrees. So that's an interesting thing and an important thing that students of science should know: relativity. Okay, and the same thing applies when uh, say a human mind works a lot on relativity. Let me tell you, in the sense that, as I said, that a person moving from warmer area to an area and a person moving from a colder area to the same area would relatively feel the temperatures to be different, isn't it? So what I mean to say is, say a person from 30 degrees moving into 19 degrees and a person from 15 degrees moving into 19 degrees would experience 19, would have the experience of 19 degrees separately. And that is what it actually means here. If I go into the technical aspects of fields, like I've already told you all that lesser the humidity, lesser the air, or on the other sense, drier the air, instead of saying lesser the air, I would say that it would bring about a lot of difference, in the sense it would feel colder. And in fact, you'll see that you go to the other end of it, you go into the rainy season where the humidity is higher. The temperatures could be lower, but it would feel warmer, basically because of the same fact that higher humidity will store in a higher amount of heat and energy, and the temperatures would sound higher. So that is another thing that I wanted to bring to your notice. Okay, day by day, okay, I want you all to go into further details. See that you visit this. This happens to be one of the first things that you do every morning. You could do it in the evening also, because there is going to be a shift in air pressure and so on and so forth. So that's an interesting thing to note. And of course, looking into where the clouds presently are, etc., also gives you an interesting aspect. Then we have done this, and we have seen how this divides the earth. Okay, then we have spoken about this, and these lines, the horizontal lines, are the latitudes, and we can comparatively speak about the characteristics. You'll see that while the left side lines are parallel, so these are concentric circles, they fit into each other and they are parallel. And here you will see that they are not concentric, and however they are equal in length. They are equal in length here, and they run pole to pole. That means they are north south, while the equatorial lines, or rather the latitudinal lines, run east west. uh, all the longitudes, I would say, converge into the poles, converge in one pole, and they diverge towards the other pole as such. And the maximum distance between two longitudes obviously is going to be along the equator, because that's the largest latitude, longest latitude, having the largest circumference, I would say. That is as far as understanding the differences between latitudes and longitudes are concerned. Latitudes are full circles, longitudes are half circles. However, two opposite half circles uh, of longitude make a complete circle, and this circle is called as a great circle. If you have read this in your school days, that all longitudes make up what are called as great circles. On the other hand, as far as latitudes are concerned, only the equator is a great circle. Now, what exactly do we mean by a great circle? Is that this latitude, or this latitude, that's the equator, and all longitudes, okay, when you are cutting through the earth, and the cut needs to pass from the center of the earth at any point of time, if it passes through the center of the earth, any angle you take, okay, now this is because we know that we are taking latitudes, that's the equator, and longitudes, all of them, but I could take it the other way also. I could slant it. The cut needs to be slanted, and secondly, it needs to pass through the center of the earth and needs to emerge at the other side. Okay, given this, okay, given this, that plane would be a plane of great circle, and that is why you'll see that all longitudes are great circles. Of course, two half circles together, they're going to be great circles, and only the equator, because it's only if you say slice the earth through the equator that it will pass through the center. No other latitude is going to be a great circle, is what you have to remember. Okay, we'll move ahead. And yes, we've spoken about the latitudes. Now let us come to the longitudes. You'll see that there's very interesting story that goes as far as longitudes are concerned. Now, latitudes, we had a horizontal plane and we called it 0. And then we measured, okay, the angles from that particular plane. Okay, let us say this pen is the equator, and then I started measuring these angles, and then I had 10 degrees, and then I had 20 degrees, and 30 and 40 and 50. Of course, they went on going smaller, smaller, smaller. And the 90 degrees of latitude is just a point, the North Pole, and similarly, you had a point as far as the South Pole also is concerned. Now, this was easier because we already had a horizontal plane. Okay, as far as measuring longitudes are concerned, I needed to identify a horizontal, a vertical plane, because I had to measure the angles from this, in the sense now, if this is the point of the longitude, I had to measure these angles away from the say a marked meridian. I'm not calling it prime meridian because we are still to come to that. Okay, so if I'm looking at it from the top, okay, and I hold it to you like this, okay, I would be measuring the angles like this. Okay, so this point is the point of 0 degrees, and I would be measuring my angles to it. Okay, so it's 90 degrees from 0 degrees, it is 180 degrees. And similarly, you'll see that I start measuring the angles this way. Okay, I'm measuring it this way. Now, identifying the prime meridian was an interesting thing. Way back in 1940s, I suppose. 1940s, 1920s, I'm not very sure about it. But all these people were meeting in New York, and they were meeting there, basic people in the sense they were scientists. They were meeting there to decide, okay, let us have a prime meridian. And now, why was it difficult to get the prime meridian? It is not the 0 degrees which was important with regards defining it. It was actually the 180 degrees, which is going to be exactly opposite to that. Okay, exactly opposite to that, which was going to be important. Now, why was that important? Basically, because the longitude exactly opposite to the prime meridian is the 180 degrees longitude. It's neither called east or west. This diagram, in fact, shows it 180 degrees west and 180 degrees east. Now, it's basically, it does not mean the longitude. It is that you are traveling 180 degrees east and you are traveling 180 degrees west. It does not mean 180 degrees west and east, because there is nothing as such as 180 degrees west and east, because it's one and the same, and it neither can be called as west or neither can be called as east. But it is also called as the international date line. Okay, because longitudes are used to measure time, okay, daily time as such. Now, coming back to this, a funny thing is that, okay, it was decided that, okay, let us have the fact that the 0 degrees meridian will pass through a place called as Greenwich, which is going to be a few kilometers, 20 kilometers east of London. Now, the moment people said it's going to be England and London, French people got very irritated. Remember, that was the period wherein England and France were not very pally with each other. They said, oh, no, we are not going to adhere to this. We are going to have our own. Okay, why should the prime meridian pass through London? Okay, let it pass through Paris. And let me tell you, literally for a next few 6 or 8 years after that, Paris had its own, or rather France had its own prime meridian. Of course, while the rest of the world was following it, okay, rest of the world meaning Paris minus Paris and its colonies in different parts of the world. But later on, of course, they realized that it was in their own benefit to join this. And 6 to 8 years after that, they said, okay, let us have Greenwich as the prime meridian, and they started measuring these degrees. Now, coming back to a few things, you'll see that from zero to back to zero, it is going to take one rotation is going to take 24 hours. So if you equate 24 hours to 360 degrees, you can calculate as to how much it would come to. So you'll see that 15 degrees comes to around 1 hour, and consequently 1 degree is going to be 4 minutes, and approximately that. So if I'm going to move from 0 to 15, what is going to happen? From 0 to 30, what is going to happen? The times are going to change by 1 hour, 1 hour on each side. Now, how do we understand this? Let me see. Yeah, okay, we'll keep this as a reference point, and before that we'll just go through these facts about longitudes. They are also known as meridians. They run north-south direction. We've already said that. They measure the distance east or west of the prime meridian. I told you. Okay, you'll see that if this is the prime meridian, this is the prime meridian. I measure the distance in degrees. Okay, remember, I'm holding, this is the Earth's surface, and I've put it to the center. Okay, and then I am measuring my degrees from here. This is 90 degrees, east or west would depend. Okay, then 180 degrees. So it's a measure of distance east or west of the prime meridian. Are farthest apart at the equator, I already told you, and they meet at the poles. Cross the equators at right angles. This is something that we missed, and that is why having a slide makes it very important. Okay, you'll see that they cross the equator at right angles. Okay, they are all equal in length, unlike latitudes, which are concentric circles fitting into each other, are half of great circles. As I said, this is one longitude, this is the opposite longitude. You meet them, this becomes a great circle because it passes through the center of the Earth. Now, as I said that every 15 degrees, sorry, now this is 10, 20, 30, so this would not work for us. This is 15 degrees. Let us keep with this. 15 degrees means there is going to be a change of 1 hour. Now, what exactly does this mean? Let us assume a fact that at 0 degrees, that's the prime meridian, you have overhead sun, that is 12 o'clock noon. Okay, 12 o'clock noon, overhead sun at 0 degrees. Now, if I am standing at 0 degrees, okay, at 15 degrees east, okay, or 15 degrees west, what could be the difference? Okay, you'll see that 15 degrees east, if 1 degree is 4 minutes, 15 degrees is going to be 1 hour. Okay, so if I am at 12 o'clock, 15 degrees here and 15 degrees there, there's going to be a variation. As far as the eastern hemisphere is concerned, there the sun moves from the Earth moves from the west to east, and that is why the sun moves from the east to the west. Okay, so while it is 12 o'clock at the prime meridian, it has already been 12 o'clock at 15 degrees east. So if it is 12 o'clock at prime meridian, it is 1 o'clock at 15 degrees east. 1 o'clock at 15 degrees east. And as far as the west is concerned, the sun is yet to move ahead. As a consequence, what happens is that at 15 degrees west, it is actually 11 o'clock. Okay, you're getting it. Okay, so the eastern hemisphere has already experienced, the whole of the eastern hemisphere has already experienced noon time, that's 12 noon, and now it is at the prime meridian, while the western hemisphere is yet to experience all of this. So the timings of the eastern hemisphere are going to be ahead of the western of the prime meridian, and the western hemisphere is going to be behind the prime meridian. Now, this is a logic that you have to keep in mind, and you have to work it accordingly. I'm coming to what exactly that work is going to be. Okay, I hope you have understood it till here, and then we continue. Okay, this, I did not take this basically because now you will understand this is 10, 20, 30, 40 degrees. I wanted it in 15 because every 15 degrees there is a shift in 1 hour. Okay, there is a shift in 1 hour, and you'll see that it's 15 tens are 150, 15 elevens are um, 15 elevens are is 175, and of course 15 twelves are is 180. So the exact opposite, 180 degrees, is going to be 12 hours. Okay, so that is what I had in mind, and that is why I did not use this. Okay, this is another way that we could measure the have a look, because I know that it's a bit confusing. So you'll see that here you have the prime meridian. This is the prime meridian here, and then I'm going to measure the angles. Okay, this is 30 degrees, this is 60 degrees, this is 90 degrees, 120, 150, 180, the exact opposite side of the prime meridian. And the same thing, this is the eastern hemisphere, this is the western hemisphere, this is the eastern, this is the western. I'm sorry, I spoke about it in a different way when I was explaining it to you. So let us now fix it that to our right we are going to have east, and to our left we are going to have west. Yeah. And another view of how these actually act as such. Okay, so these are latitudes, and then sorry, these are longitudes, and these are various lines of longitudes as such. Now, an interesting thing is that uh, the Earth is curved, right? And that is what makes things very, very interesting. Why did we go all the way to have a so-called prime meridian, and we have what is called as the GMT, and why is it that countries actually relate national timings to the GMT, that's Greenwich Meridian Time? Okay, it's basically because, as I've already said, that longitudes help you to measure time, and now that the whole world wants a time connected to some time, that means, say, we need to start with a point wherein, okay, the world starts its day at this particular point of time, and the world ends its day at this particular point of time. Now this all happens technically. Okay, it doesn't happen actually, because every country shifts its dates accordingly, according to them. But this shifting is in relation to something, and that is Greenwich Meridian. Now, why did we go all this way? Remember that when man did not travel much, say a few centuries ago. Now, of course, all of us are traveling, but a few centuries ago, only traders were traveling, and of course, the population of the world also was not that much. So we did not have people traveling then, and the sense of time then was very interesting. In the sense, before we started speaking about time, in the sense we had say time as watches as such. You must have seen those English people who had those watches dangling down their hips, and they used to just see what is the time. I'm speaking about the time before that, when time was just being a unit. Okay, and then you must have seen those hour glasses in the Roman Empire that they shifted, and so on and so forth. I want you to go before that. How did we measure time then? Okay, you will see that initially man did not measure time so precisely, and the scale of time, because we are geographers, we never have to lose sight of the concept of scale. As I said, that for 100 meters dash today, you divide a second into 100 parts, and that is called as milliseconds, and so on and so forth. But you'll see that as far as a normal layman is concerned, you don't work on that scale, milliseconds and so on and so forth. So when man started looking, you'll see that there was something which is called as sunrise and sunset only. Okay, sunrise and sunset. Then came in a time wherein the sun came overhead, so that came to be noon time. So you divided the day part into sunrise, noon, and sunset. That was it. And after the sunset, the whole section was called as night. Midnight comes much later. Okay, so you'll see that. And how does this come up? This concept come up? This concept comes up only with the sense of a working time, because man used to work during the daytime. He wanted these times to be separated, and that is why you'll see that you had morning, then you had noon, and of course then you had evening. Okay, then you introduce what is called as afternoon, and then you had what is pre-noon, because you started dividing time further. Okay, night was night. Okay, sunset was night, all the way till from twilight to dawn, everything was night, because man was not functioning then. Today, yes, man is working 24 hours, and we have divisions of that also. But as far as daytime then was concerned, you started with sunrise, noon, sunset, then you said pre-noon, post-noon, and then you started you brought in one more thing, that is called as you said sunrise, then you said morning, then you said pre-noon, then you said noon, then you said post-noon, then you said evening, and then you said sunset. So we went on going into that. Now, there is a concept which is called as local time. Local time. Okay, you'll see that when we speak about local time, it basically means that if you have done your regional geography of India well, we know that the distance between a place which is to the westernmost corner in Gujarat of India, that's Dwarka, and if you go to a place to say the eastern border of India, let us say Valong, you can search for both these places on the weather and radar map. Both of them are there. WALONG, Valong is in Arunachal Pradesh, Dwarka is in Gujarat. Okay, the distance, the longitudinal distance between these two is 30 degrees of longitude. 30 degrees of longitude. Okay, now if 15 degrees is 1 hour, 30 degrees is going to be 2 hours. What does this geographically mean to us? Okay, mathematically it is a division of 20 degrees of longitude between these two. But you'll see that when we come to the geographical aspect, okay, the sun will rise much earlier. Okay, as far as Arunachal Pradesh is concerned, as compared to Dwarka. In fact, you'll see that it will rise there 2 hours early. 2 hours early. And a bit of complexity I would further introduce in all these things is that the Indian Standard Time is with reference to the central meridian of India. Central meridian of India. And that is 82 and a half degrees. And this passes near, I think it's east of Allahabad. Okay, and it goes near to Nagpur also, that central meridian as such. So you'll see that if I'm saying that the sun rises at 6 o'clock in India, 6 o'clock in India. Okay, this 6 o'clock is with reference to the time at Allahabad or the central meridian of India. Okay, the central meridian, okay, of India and not the world. Okay, we were later going to relate this central meridian to the prime meridian. We're going to come to that. Okay, so you'll see that it so happens that if we say it's rising at 6 o'clock in India, okay, you'll see that 1 hour it has already risen there. Okay, in Valong, in Arunachal Pradesh. Okay, so you'll see that when when I say that it's sun rising in India at 6 o'clock, I go to Arunachal Pradesh, I look at it 5 o'clock in the morning and it's already rising. On the other end, I go to Dwarka and I see that 6 o'clock, it's still dark. I have to wait till 7 o'clock till the sun rises. And that is how the difference comes. But the averaging is done with reference to the central meridian, or what is also called as the Indian Standard Time, which is with reference to the central meridian of India, which passes near to Allahabad. That's 82 and a half degrees. Now you relate this 82 and a half degrees to 0 degrees, 0 to 82. Okay, and you divide these 82 and a half degrees by 15. Okay, 15 5s are 75. 15 5s are 75, and you are left with another 77 degrees of longitude. Okay, that would come to around half an hour. So it's going to be a difference of 5.5 hours. What does this mean? Now, just like we were speaking earlier, if it is noon time at Greenwich, India is 5.5 hours ahead. So it is already what time? It's 5:30 in the evening as far as India is concerned. It is 5:30 in the evening as far as India is concerned. That is one thing that we have to understand. So you'll see that places within the same country were confusing, and that is why from local time we moved to national time. And there was a confusion as far as national time also is concerned, because initially some people suggested that since India had such a large east-west extent, what should be done is we should be having two standard times. Okay, two standard times, and that was a very wise advice then. But given the fact of that the literacy was very poor and a significant part of Indians live in rural areas and they were not in touch, okay, with the urban areas and all those things. Okay, Sardar Patel said that nothing doing, we are going to have one time. Okay, and that is why, because we have one time for such a large an extent, you'll see that while the sun rises at 4 o'clock in Arunachal Pradesh, it rises as late as 6 o'clock in Gujarat. But and you'll see that adjustment to this is called as daylight savings, and you'll see that during during certain parts of winter, okay, the temperate countries, particularly in Europe, going to what is called as daylight savings. Daylight savings is now coming up as a practice in northeastern parts of India also. In the sense, you'll see that because it rises early there, particularly in winter, okay, because the day becomes less. Okay, and if you keep timings as they are in the central parts of India, say for example, um uh, mm, let us say the bank timings are from 10 o'clock to 4 o'clock in the evening, and the same timings need to be applied in Arunachal Pradesh. What happens is, if you check on the weather and radar app, okay, you'll see that the sun has already started setting early as far the eastern parts of India are concerned. So by the time the bank closes, it would be dark. And so what they do is they shift their working hours, and that is called as daylight savings. Okay. Okay, coming back to the fact that how do we adjust all these mechanisms as such? Okay, because we are 82.5 degrees east of prime meridian, we are 5.5 hours ahead. Okay, now if I am traveling, now comes the real sense of it. If I'm traveling from London to India, okay, I start at 12 o'clock. I start at 12 o'clock, noon, the flight takes off, and the journey is 5 hours. So I should be reaching here at 5 o'clock evening, but that is going to be London time. London time, right? What by the time I reach here, my clock says it's 5 o'clock in the evening, but my wristwatch says it's 5 o'clock in the evening. But India has moved ahead by another 5 hours, so it's 10:30 in the night in India. So when you're moving east of the prime meridian, you are losing time. Okay, the fact that eastern hemisphere is ahead means that when you travel east, you lose time. When you travel west, you gain time as such. Okay, now this is not only with reference to the prime meridian. Say, for example, now we take a mechanism saying that uh, Mumbai is going to be the central point, and Singapore in the east and Dubai in the west are going to be 2 points. Okay, let us assume hypothetically that the journey to Singapore and Dubai is going to be 2 hours, and it is going to be noon time in Mumbai. Noon time in Mumbai. And let us also assume that the difference between the time is 1 hour. All this is hypothetical. It's basically to understand what actually is happening. Okay, so say the distance is 2 hours. So if I am starting at 12 o'clock afternoon from Mumbai, I'm flying towards Singapore. Okay, the flight is going to take 2 hours. That means I am supposed to be reaching Singapore at 2 plus 12 plus 2, that's 2 o'clock in the afternoon. But the time difference is 1, so I need to add another one. So I flew from Mumbai at 12 o'clock. When I reach Singapore, it is 3 o'clock in the afternoon. I've traveled for 2 hours, but the time difference is 3 hours. So I've lost 1 hour somewhere, I don't know. And that is why when you travel eastwards, wherever you are, it does not necessarily have to be the prime meridian. Wherever you are, if you travel eastwards, you are going to lose time. You're going to lose time. How? You'll see that you started at 12 o'clock. You're supposed to be traveling for 2 hours. So by the time you reach Singapore, it should be 2 o'clock. But because Singapore is 1 hour ahead of us, okay, you add another hour. So it's already 3 o'clock there in the afternoon. It's already 3 o'clock there. So you have lost 1 hour. Exactly opposite things happen when you travel from westwards. You take catch a flight the next day, let us say, from Mumbai, and now you're traveling to Dubai. You're traveling, you are traveling for 2 hours. Okay, you are traveling for 2 hours. So again, you're supposed to be reaching there at 2 in the afternoon. But because it is to the west of Mumbai, okay, the time difference is -1. So while you were supposed to be reaching there at 2 and you land at the airport and you come out and you see that it's still 1 o'clock there. Okay, so you're supposed to be reaching there at 2, but you have reached that at 1. That means you have gained 1 hour. From nowhere you get, and 1 hour you keep it in your pocket. But when you travel eastwards, you have to expend 1 hour from your pocket and you give it to the country you are landing into. You have lost time when you go to fly towards the east. You lose time when you fly towards the west. Now, what decides this east-west? Okay, you'll see that this diagram here, this one. Okay, you'll see that. Let me put it this way. This is basically from your Balbharti book I've taken. Okay, you'll see this is 0 degrees meridian, and this meridian is passing through London, if you can see on the map here. This guy, his name is Sunil, he starts walking east, and this girl Meenal, she starts walking west, and you'll see both of them are going to reach here at mid. And if this is noon, if this is sorry, if this is going to be noon here, if this is going to be noon here, okay, midday, noon time, you'll see that it's at the same time it is going to be midnight at 0 degrees, at 180 degrees meridian. And that is why this is also called as the international date line. And here is where the concept of changing the date comes in. Okay, so when you are in the Western hemisphere and you move to the Eastern hemisphere across the international date line, from west to the east across the date line, you are going to lose a day from Western hemisphere to the Eastern hemisphere. At the international date line, you're going to lose a day. When you move from the Eastern hemisphere to the Western hemisphere, you will gain a day. Now, there are many complexities as far as these operations here are concerned, but very simple. You move east, you lose time. You move west, you gain time. There's one more thing that we need to understand as far as the international date line is concerned. While all the longitudes are, say, curved very smoothly, you'll see that the international date line, however, is not curved smoothly. Okay, it is going a bit here and there as far as these parts are concerned, and then of course here also. Why has this is basically a human convenience, for human convenience, because all these islands here and this part is United States of America. The islands to this side is going to be Russia. Now just imagine that if we had pushed it all the way straight here, what would have happened is this part of Russia would have been in a different part of the day, while this part of Russia would have been in a different part of the day, to avoid that technical confusion. Similarly, you'll see you have some islands here. These islands belong to one particular country. These islands belong to one particular country. So that there is no confusion of day. It's not only hours, it is day within a particular country. What they have done is they've just shifted. Now imagine if we had done same with France as such. If Paris would have been the prime meridian, it would have been more difficult to get this, and that is why it is advised that the best place is across, say, London, or rather the other side of London, which is the prime meridian. Okay, now I'll just read this here. Person traveling to the west will add a day after crossing a day. That means he will gain a day. Person traveling cross will continue east, will continue with the same day after crossing the international date line. So you're going to lose, but the timing is going to change as such. Okay, so this in short, basically you start with the geographical time, okay, your time, okay, the place you are. Then you see a place which is a few hundred kilometers away from that. So you require what is called as a local standard time, or you require a national standard time. But that national standard, you see, every country will have their own national standard time, isn't it? And that is why all national times of different countries need to be linked to one particular time, and that is international standard time. So Indian standard time, international standard time. International standard time is according to the prime meridian. This prime meridian is nothing but the longitude passing through Greenwich, which is 20 kilometers to the east of London, and it passes from there. So this is the whole story about, and all this happens basically because the earth is curved. Had it been flat, the equation would have been completely different. It's curved, it's rotating, and it rotates from the west to the east, and that is why, okay, when it rotates from west to east, now you'll see that if this is the sun, this is stationary, okay, and you'll see that if this is the earth and it's rotating from the west to the east, okay, what happens is the sun seems to rise in the east and it tends to go to the west. Okay, this is the, say, we assume that this is the west. Okay, west to east, it moves like this. The sun, it is there. You'll see that you feel relatively that the sun is rising in the east and it is setting in the west. You can go into the details of two clips on latitudes and longitudes, which I have on this very channel. If you have not subscribed for this particular channel, or you don't need to, I'm not going to force you to subscribe to my channel. If you find it interesting, you can subscribe. If you don't find it interesting, just attend lectures. It hardly matters. Okay. If you find value in my lectures, yes, you could subscribe. And it is in these very lectures that you have those two clips, one on latitudes and one on longitudes. I have animated them, and you can. I hope you can understand what when I'm speaking about latitudes, you understand the whole context of latitudes. When you're looking into the clip on longitudes, you understand the whole concept of longitudes as such. So you can add on to your information by just going through those two clips on latitudes and longitudes respectively. So this is as far as latitudes, longitudes. As I said, this is not going to be a part of your theory syllabus, but it's a part of your practical syllabus. And I did not want any confusion as far as understanding latitudes and longitudes is concerned. If there is still any confusion, you can post your questions in some time from now. I will go there. I will see if I can answer that, or you can post your questions on our WhatsApp group also. I'll try to answer it there, or I'll take it up next lecture. Of course, next lecture, remember, it's going to be tomorrow, and then we're going to have a break of 1 week. And then we meet after that. So probably after tomorrow, that's after 10th of November, we are supposedly meeting on 23rd of November, provided there is no change in the timetable. If there is a change in timetable, then of course we'll see what else is to be done. But 16th and 17th, 16th is official holiday, 17th I am going to be on leave, so we would not have our lectures on 17th, 16th and 17th. I'm not actually sure what the time is. It's 10:21, so 10 minutes to go, and I wanted to go into other parts, but I don't know. Yeah, this is okay, a slide where which on a flat surface, if the earth was to be flat, this is how the international dateline would look. And then you'll see here why they have just twisted it. And you have this string of islands which are called as Sakhalin Islands, which belong to the Alaskan, sorry, these are the Alaskan Islands, and these belong to the United States of America. That's the 49th state. And of course, you have Hawaii also somewhere here. So all of that had to be in the Western Hemisphere. It would have been very funny if the Hawaiian Islands would have been in the Eastern Hemisphere and the rest of the 49 states of the United States of America would have been in the Western Hemisphere. It would have been very difficult for them to set things right, okay, in legal and other terms also. Okay, then if you look into the syllabus, okay, which I would try to bring up in some time from now, or let us see when I can bring it. I can bring it up next tomorrow also. Let's see. I need to tell you all that one of the topics, if your first term is first chapter is the geological time scale, and I believe that students of science need to understand this scale of time. Okay, this is based on how long the Earth has existed, and with various evidences that we have had. Uh, it's an attempt to explain what has happened on this earth for so many years. Now, if you ask me how long has man been on this particular planet, I would say he has been on this planet for not more than 5 million years. 5 million is equivalent to 50 lakh years. 50 lakh years. But how old is the earth? The earth is they round it up to 4.5 billion years, but some people believe that it is 4.6 billion years old. You can see here it's 4.6 billion years old, and we are somewhere here. Okay, this is billion. 4,600 million means 4.6 billion. Okay, and this is 500 million, and then you come to this, and it's going to be 100, and then you could divide it further. That's the 50 million, and then you come to 5 million, and you can just imagine how recent we are on this particular planet. Just to give you an idea, I will try to put it up in this particular format. You'll see that these are, of course, this is the larger form of life. This is just 600 million years ago. Okay, and this is where larger forms of life started coming up. You'll see students from botany and zoology would know this. Okay, you'll see that these are the animals first, and then this is how life developed further and further and further and further and further, and then you come to this Triassic, Jurassic, Cretaceous, where you have these dinosaurs, and then of course you move ahead, and it's finally you come to these last few periods of time in history, and where you have the evolution of humans, and now you have started bipedal motion. Remember, we spoke about bipedal motion, bifocal motion, cranial index. Okay, the head size is larger, the brain size rather is larger, uh, um, as far as human beings are concerned. It's a very interesting thing to do in science. Okay, particularly when we are going to go now. See this Cambrian. Okay, this Cambrian is somewhere here. Here. Okay, now this Cambrian is somewhere here, and the Earth has been in existence much before that. Okay, so what we speak about Cambrian that looks so long to us is not more than 500 million years. And in fact, the Earth is 4,600 million years old. So how this has worked and how scientists have calculated this is a very interesting story. We'll take it up tomorrow. But let me tell you that there have been different measures through which scientists have tried to measure the age of the Earth. And in fact, just like we have some religious bigots these days around us, say the 16th 17th century was the time wherein you had these religious bigots in Europe as well, and they thought that God made this particular faith is one thing, and trying to push that faith into someone else's faith into your throat is something else. In fact, you will see that this lecture that we will of course not be going into the details today, but when we take it up tomorrow, I have based that lecture on two references. One is, of course, a book on geomorphology by P. Dayal, who was the former vice chancellor of the Patna University, an excellent book on geomorphology by P. Dayal. And then there is this documentary by the BBC, and which was screened on the History Channel, how the Earth was made. It's very normally when we are on campus, I show this documentary in two lectures as far as these classrooms are concerned, but obviously these days are such that we are not able to meet each other in person. We are meeting virtually. So I'm trying to think of a way as to how I should be screening that movie to you. But before that documentary, let us understand what all this is. So my references are these two. Okay, a theoretical reference from Professor P. Dayal's book, and of course some interesting facts to make the lecture interesting from the documentary how the Earth was made. Okay, I'm looking for answers. If you have any suggestions as to how can we screen that movie online, the documentary online, it's not more than 90 minutes. Okay, I stop it at points and then I give a bit of commentary, so it may go into 2 hours, but we can split that also. At one point of time we can do it for 1 hour, and then the other point of time we can do it for another 1 hour. Okay, if you have any suggestions as to how we could go into it, screening it virtually so that all of us can enjoy that, you can just let me know. For now, we'll stop here today. Tomorrow we'll go into this interesting aspect, the geological time scale, and let us see if we can enjoy this next time. Okay, now if you have any questions of what we have done, I'm sure you should be having questions as far as the timings are concerned. Okay, because at one go, even I didn't, as a student, even I did not understand east west. So if you have any questions, you can ask me those questions as to timing, local time, geographical time. Geographical time is with the time in relation to the sun. Okay, sunrise, noon time, sunset. That's geographical time. Standard time, national standard time, is with reference to a longitude. When you relate that longitude to the universal standard time, the Greenwich meridian, then of course you work out the geometrics of it, and then you work out the number of hours that shift from here and there. As I said, if you move east, you are losing time. If you move west, you are going to gain time, and so on and so forth. So that is about the time and the importance of longitudes and latitude. Latitude. So first function is to give you a pinpoint location. The second function of latitudes is to give you climatic regions. The second function of longitudes is to give you regional time, okay, with reference to a standard time as such. So these are a few things that we are supposed to be doing today. Tomorrow, I plan to take geological time scale, but before that, I also plan to discuss the our syllabus, so that you get a technical link into what are we doing, why are we doing, how to link your studies, and so on and so forth. I've already posted links, my Google Drive links of the 11th and 12th standard books, NCERT books. So you can use them as a reference. You have to use the things that we do in our lectures. You can make notes, and you start making your notes, because you'll see that you come back from Diwali, and 15-20 days down Diwali, let me tell you that you would have your first assignment, or you could have your first test. How that is going to be conducted will be told. Say in these times, it should normally be the MCQs. So you have to be very sharp and understand what we have done. You can go through all the lectures. If you have time, you can go through my arts lectures also. 60% of the content is the same, but normally given the mood on that particular day, 40% of the content changes, and of course you could find that interesting also. Anyway, that's all for the day. We'll stop here today, and we'll meet tomorrow for a fresh lecture, and we would be speaking on the syllabus and of course more on the geological time scale. It's a very interesting thing as far as the age of the earth is concerned. I will be somebody has posted a question. I don't know why I'm not able to see it here. I can see it. Yeah, here. Now it comes. Prajwali Kirat says, sir, east towards prime meridian, we add time, and west towards prime meridian. East towards prime meridian. No, we lose time. We lose time. Okay, if you are going east, okay, you are not towards prime meridian. Prime meridian is one reference. Then if you are individually moving towards Singapore and or Dubai, you are traveling east or west. If you are traveling east, you are going to lose time. If you are traveling west, you are going to gain time. Okay, now what this says is that, sir, towards east prime meridian we add time, and towards west prime meridian we lose time. That's what I'm saying. That's what I'm saying. Yes, and of course JC Leong is a very good writer, and of course he means business. So it's nothing wrong. It's only the context with which we need to understand these things. So Prajwali, what you are saying is absolutely similar to what I have said. Okay, it's only that you have confused yourself by putting that towards prime meridian. Okay, don't see if now then the say context goes further beyond that. Okay, from east. Now see, from if India I go to the prime meridian, I'm actually traveling west. From India I travel to the prime meridian, I'm going west. So don't use the prime meridian as a concept if you want to understand what is gaining time and losing time. If you travel east, you are losing time. If you are traveling west, you are gaining time. Any other difficulties, or if you still have not understood it, we could discuss it on our lecture tomorrow, or you could discuss it in the group as well. That's all for today, I would say. And till we meet tomorrow, stay home, stay safe.